Good evening, everyone. So, I welcome you all to the live session number 7 for the course Affective Computing. And sorry for the delay because there was some technical difficulty, so we are running slightly late. But this recording will be available on YouTube, so you can refer to it later. So, I hope the session will be useful for you. Now, in this session, we are going to discuss about emotions in physiological signals. And these sessions focus on more problem solving and discussion aspect. So we will start with some questions from previous year assignment. This weekly seventh week assignment from 2024. Then we will move on to some questions from 2023, and then some extra questions on practice. So first question is, also I strongly recommend you, for those who are watching this video later, that you pause for a while and try to answer the questions and then move on to the solution part. Okay, so first question is, physiological signals originate from the activity of the autonomic nervous system, which means they cannot be consciously or intentionally controlled. So what exactly are physiological signals? Physiological signals refer to some measurable electrical, chemical, or mechanical changes in the body that reflect the activity of different bodily systems. That means these reactions are generated by the body's response to various stimuli. Meaning, let's say you are stressed, then your body will behave certain way, and these signals are not really controllable. Like these actions actually are not controllable. These are involuntary movements or activities which are happening in your body. So it can include like stimuli such as some stress, emotion, physical exertion, or changes in the environment. Now, these physiological signals are often used in the fields like health monitoring, affective computing, biometrics, etc. And some of the examples of these physiological signals include heart rate, EEG, which is for the brain activity. Then comes the ECG. ECG is for the heart rate, heart activity monitoring. Skin conductance. Skin conductance is for the skin response. Hi, Krishna. Thanks for joining. So, I'm really sorry the session was delayed due to some technical error. I just started, and this is the first question that I'm discussing. So, I hope you will participate in this discussion. So this is the first question. Let me go back. So first question was about, since the we are discussing the content of week 7, which is focused on physiological signals and emotions. So this is the first question, and these questions are from the previous year assignments. Um, So we are talking about the physiological signals, and they're often used in health monitoring and effective computing. Now, the some of the examples I was discussing are heart rate, EEG, ECG, and um, other maybe let's say breath rate or something like that. So then physiological signals such as heart rate, skin conductance, and respiration are primarily controlled by the autonomic nervous system, which is ANS. Now it governs the involuntary function. As I mentioned, these physiological changes that happen are involuntary. You cannot control your sweaty palms when you are stressed or when you are scared of something. So these physiological signals typically occur without conscious control or intentional manipulation. So let's say heart rate and skin conductance automatically change in response to physical or emotional stimuli, and pupil dilation, other reflective responses to stimuli are also automatic. Now, some aspects, some activities such as breathing, we can somehow control how fast or how slow we are breathing, but up to some degree through conscious control. However, the origin of physiological signals, um, especially in the context of emotional stimuli, let's say you're scared, so you will like start breathing heavily. So it is ultimately rooted in the ANS. So we can say that these signals generally cannot be consciously controlled or intentionally controlled. So the correct answer for this question is true. The question discussed about uh, whether we can consciously control or not about these physiological signals. Okay. So next question is, what is heart rate variability measure? Now, a very important measure of signals. Uh, since we we do you know about ECG? So what exactly happens? It looks something like this. There are some peaks and then dips. So it somehow it looks like this. So what happens is that this uh, heart rate variability, especially, it measures the variation in time intervals between consecutive heartbeats. Now you can say, see, this is the peak peaks that we are observing, and the duration between these peaks is very constant, 1 second. After every 1 second, the peak is observed. But in this case, the time duration between two peaks is varying slightly. Then heart rate variability, what it means is, here it is not varying much. The duration is not varying much. That means it has low HRV. However, this is varying very much. So this is having high HRV. Now, what is related to this high and low HRV is, for low HRV, we usually say that it is not considered good. It is not considered good. If you look at this, you might think that this represents a healthy heart, but usually it's not the case. Why? We will see in a while. Now, low HRV refers to flight or fight, easily exhausted, low adaptability, and decreased cognition. That means this is not considered good. Now, coming to high HRV, there is rest and digest mechanism, improved performance, high adaptability, and improved cognition. What happens is, okay, let me just define it formally. So, it specifically looks at the differences in the length of time between each heartbeat, known as the RR interval. This peak is known as R. So the difference between in any ECG findings is called HRV. So typically uh, in a healthy and adaptive is the keyword here. Adaptive autonomous nervous system. The heart is capable of varying the time in response to different physiological needs. Let's say I am in a rest state, so my heart should adapt according to the situation, according to the state that I am in. But if I'm stressed or if I'm exercising, then my heart should also adapt. So that means our heart should not be beating constantly. There should be some variation. Let's say if my body needs more blood, then the heart should work faster, and it should be able to adapt to the situation. So low HRV means low adaptability. So it suggests that potential stress, fatigue, or any underlying health issues, and it indicates that the heart is not as flexible in adjusting the time between the beats. However, if there's high HRV, so we considered it more healthier. So the options were the average heart rate over a specified period, no. The variation in time intervals between consecutive heartbeats, which is true. Then the strength of heart's contractions, the number of heartbeats per minute. So second option is correct. Then, increased heart rate variability has been demonstrated to correlate with the relaxed state. We just discussed that. Increased heart rate variability, that means, so yeah, it is generally associated with a relaxed state and better adaptability to stress. When we are relaxed, or when the parasympathetic nervous system is activated when we are in a relaxed state. Now, when this nervous system dominates, it tends to increase. So we become more like passive and our heart is more adaptive. So it reflects a more flexible and adaptable heart rate in response to changing conditions. Now, this flexibility often correlates with relaxation, reduced stress, and better overall heart health. So, in contrast, as we have already discussed this, low HRV, it might indicate stress, anxiety, fatigue. okay, where the heart rate becomes more rigid and less capable of adjusting to varying demands. So increased heart rate variability correlates with relaxed state. This is true. Hi Vishwesh, good to see you again. So this session was delayed by almost 50 minutes because of some technical fault, but we're back here, and so this is just why this is the reason we just on question number 4. So anyways, let's move on. Which of the following methods is generally considered a more accurate measurement of the heart rate? Is it ECG, photoplethysmography, PPG? I'll call it PPG. Both have equally accurate measurements, or none of the above? So would you also like to participate, Krishna and Vishwesh? I'll wait for just 30 seconds before moving on to the explanation. So option A, ECG. Okay. So what is exactly ECG and what is PPG? Let's see. ECG is a method which is used to measure the electrical activity of the heart, because heart beats and it generates some kind of electrical signals which we can capture using these electrodes. These electrodes are there placed on the chest region, and then we can observe these kind of readings on the screen. This kind of indicates a healthy heart. If the this is more of a like uniform heartbeat pattern, then it is considered a healthy sign of a healthy heart. Now, these electrodes, these capture the heart's electrical signals through the electrodes placed on the skin, usually on the chest, arms, and legs. Now, how it works is that it detects the timing, like as we will discuss in a while, that there are some peaks. These are called R peaks. I think we call it Q or QSR something. So the ECG detects the timing of heart's electrical impulses as they travel through the heart muscle. Okay. So these electrical signals control heart's pumping action and create a pattern that can be recorded and analyzed. So what are the advantages of ECG? This is highly accurate because there are electrodes, and it is taking some like the readings with good precision. It provides detailed information. Okay. Also, it is very useful in the clinical settings. Usually, this is used. What are the disadvantages? It requires electrodes to be attached to the body. So it is not as convenient because you have to attach it to the body. Also, it is called like it is more invasive. I would say invasive. ठीक है, often requires stationary conditions, like you cannot move, and physical activity is very limited, and daily life activities we cannot do it unless a portable ECG device is there. Okay, but in the case of this PPG is a non-invasive method. Do you remember during COVID times we had this oxygen meters? So it measures the oxygen amount in our body, you know. So how does it do that? It is just clip on thing and then it measures. It is also related to the heart's activity. Now, this is a non-invasive method, sorry, used to measure the changes in blood volume in the microvascular bed of the tissue. So, it is often found in wearable devices like smartwatches, fitness trackers, and oximeters. So, PPG uses a light source. What happens is there's a light source you can see. Uh, we there's a this is a sensor, and let's say we are just projecting the light on our finger, and how much is reflected and how much, let's say when there is high pressure or the pulse is like coming, the blood is pumping the blood, it will reflect some different amount of light back to the device, to the sensor, and similarly and it can measure the, like whenever the blood is being pumped, so a capillaries carry more blood, so it behaves slightly differently, so you can capture the pattern. Okay, so that can be used to detect heart's activity. Let's say this is very equal intervals, so you can say that it is heart is beating at a very constant rate. Let's say the HRV is uh, constant, low. So similarly, why is this used? This is non-invasive, of course, and it is not as accurate as ECG because we are ultimately guessing or approximating, because this is just using the light source. Now, why is it not accurate? Because ECG involves the electrodes placed on the exact points. However, PPG is prone to noise. How come? What can be the noise? Let's say there is a light source, or you are in a very bright environment. The light from outside can also leak into the sensor, or other can be like some other since it is also kind of electronic magnetic something signals, so some interference might be there from other devices. And also skin conditions. Let's say my skin and a person from other country having some white skin, or a person with very like dark skin, the sensor might fail to identify the I mean the blood flow with a good precision. So it is very like it is used mostly for non-clinical or day-to-day monitoring. So it is good for approximation but not for exact precise diagnostics. So it is less reliable, however. So that's why we use ECG. Next question is, what is the typical sampling frequency of galvanic skin response? Since we have already discussed what is galvanic skin response, I'll just briefly explain. Whenever we are experiencing some kind of arousal state, so what happens is as the skin activity of the sweat glands which are present underneath our skin, they they're more activated. So usually in the situations when you are experiencing fear, or you are you are very tired, or your heart is racing fast, and then you will experience sweaty palms. Okay, you are very nervous, let's say, then also you experience and sweaty palms. So this is due to the increased activity. Now, whenever the activity is increased, the electrical conductance, the ability of your skin to conduct the small electrical signals, it increases a lot. So that is how we capture it, and it is called GSR. Now, what is a sampling frequency? Sampling frequency means how often do we need to take a sample. Um, let's say you are taking, you're measuring something. Let's say I have a sensor. Okay, I have a sensor, and then you cannot just take a reading for every microsecond like that. Okay, it is very difficult. So what we can do is, let's say I'm taking measurement after every 1 second. First reading will be at 1 second, then will be at 2 second, 3 second. So that is so my frequency becomes how many times I'm doing this in a second. It is like one reading in 1 second. One reading in 1 second. That means 1 hertz. Okay. So but how many times in GSR we are taking the readings? This is just for your understanding. For GSR, what is the typical range? So sampling rate for GSR is typically so what happens is these signals, let's say we are talking about skin conductance and ECG or EEG. So these EEG signals, they change very quickly. We are like brain is very fast to process things. However, our skin, let's say I'm sweating, it won't happen that I just started sweating in 1 second and next second I stop sweating. But it is a more gradual process and slow process. That means it will stay for a while. The effect will stay for a while. But in the case of other signals, let's say ECG or EEG, this this might change very quickly. Within seconds, the readings might differ. However, not in case of GSR. So it is okay if we take more slow readings of that. So the frequency is typically 1 to 10 hertz. So 1 to 10 samples per second. It is sufficient. Why? Because JSR changes occur over seconds rather than milliseconds. Okay, and making high frequency sampling unnecessary. We can still take 100 samples per second. However, it is not required. It will just not capture some meaningful differences, and it might waste your memory or space requirements. Okay, so lower sampling rate still captures meaningful changes in skin conductance levels associated with stress, anxiety, emotional arousal. uh, let's say person is experiencing anxiety, so the sweat glands become more active. Sampling at a frequency of 1 to 10 hertz, it allows the researcher to observe these slow variations in GSR over time without overwhelming the data storage or resources, because the more data we capture, we need more resources, we need more storage to process the data as well. So usually it's 1 to 10 hertz. So next
Ma'am,
question is,
excuse me, ma'am.
yes, Krishna, please.
Ma'am, as you say, it's a gradual process and slow process.
Yes,
It's 1 to 10 second is enough. How
1 to 10 seconds नहीं है, 1 to 10 readings per second.
1 to 10 readings per second?
Yes.
Okay. How long it how long it take? Sometimes I need the time, exact time.
What exactly are you asking? Like how long we?
How long we measure the.
It is up to you. Like let's say देखो maximum readings you can take. uh, Usually what happens is emotions last for some minutes, I would say, or some maybe 1 minute. You will, let's say you're laughing, so
Okay.
typical duration will be 1 minute or 2 minute. You will stop laughing after that, right? So the
Yeah.
skin will also change accordingly, the conductance. So it depends how long you want to take the measurements. But the difference will be observed. Now, maximum reading is not the problem, like the duration for your measuring. As long as the person is available or the device can be put on the person, you're free to capture the samples. However, the problem comes when we are talking about the sampling rate, which is the minimum samples. Let's say I'm taking reading at 1 second and 2 seconds. However, there is some EEG, let's say EEG signal. Now, EEG signal changes 5 times within 1 second. Okay, let's say I break down this, let's zoom into this. There are 10 milliseconds in 1 second, 100 millisecond, whatever. So every block it is changing. So,
Yeah.
but if I capture only one reading, it is possible that I may only capture this and miss out on the other readings, right? So it is not the right approach because it is very fast changing. However, the skin conductance, if it is changing, then it will change over a duration of seconds, not the milliseconds or microseconds. So
Oh,
it
okay,
is,
ma'am. Now
got
clear.
it.
Yeah, yeah. I got.
Huh. So that is we are talking what we are concerned about.
Okay, okay. Thank you.
Okay, so the next question is, why is it important to introduce a gap between stimuli during experimental presentations? Last time we discussed that we present experimental design. We discussed that, let's say I show you some videos to make you experience some kind of emotion, and I capture your response. Let's say facial expressions. Now, since I want to capture those perfectly, so why is it important to introduce a gap between the stimuli? Stimuli means the video or the anything that I'm showing you to induce some kind of emotion. So to increase the overall duration of the experiment, to minimize overlap of responses, to reduce participant fatigue, to maintain a consistent rhythm in the presentation. B. Okay, Vishwesh is saying B. Ha. So what happens is that, let's say you show me a comedy movie, for let's say comedy movie clip from comedy movie, and I the person is experiencing laughter or happiness. Let's say then he stops. But let's say you show me a happy clip, and without any gap you start showing me a sad clip. Now the transition will be very fast, and I won't be able to capture the essence, like the actual thing when it was happening when I was feeling happy. Because while I was feeling happy, you introduced some sad clip. Now I started like experiencing some kind of sadness. So there is some kind of ambiguity in this area. What am I feeling? Um, am I happy? Am I sad? So it is not the right way. What happens is we don't want the responses to overlap, because we design these experiments to analyze the difference between the emotional states. So let's say I introduce some kind of gap, and this gap can be, let's say, you can project the next video starts in 3 2 1. So during that duration I will be mentally prepared and I will be in the neutral state, so that before jumping onto the next video, next stimulus, I will be on the baseline. I will be back to the neutral state. Let's say this made me laugh for a while, but then after watching this, I'm at the neutral state, and now I can experience again, and I'm starting fresh. So that is why we introduce some gaps. Let's read this out. Introducing a gap is crucial to avoid overlap of responses from one stimulus affecting the response to the next. Because if I'm laughing here, then I might remember the previous video and keep laughing while this is a sad clip. So it won't be able to capture what exactly would have I felt if you wouldn't have shown me the previous clip. I mean, isolated results you won't be able to capture. Now, the response time, sometimes what happens is, again, emotion is not like you are experiencing happiness and then it drops suddenly. It reduces also gradually. You start laughing, then you calm down slowly. So it is this. It goes like this. ठीक है? This is the maximum emotions, like intensity state. Okay, then it starts reducing. So that is how it works. If you start the next, तो उसका ग्राफ ऐसे ओवरलैप करेगा. However, we don't want this. We want this, and then next emotion like this. So I hope you are able to understand this. That is why we require some gaps. Now, clear interpretation is also a benefit because it allows us to better interpret and analyze specific response to each stimulus without its residual effects from the previous one. Same thing. Physiological baseline, of course, as I mentioned, we require the person to calm down and then start fresh for the next video. So that is why ensuring that each stimulus starts with a clean slate. That's why we introduce the gaps. So second is correct. Now, EEG can measure changes in brain activity over short time intervals, often in milliseconds. True or false? False. Okay, let's see. See, EEG. Do you know EEG? EEG, like we wear a skull. Uh, I mean, skull cap filled with the electrodes, and these capture our brain activity signals. Now, one thing about EEG signal is that it is high. It has high temporal resolution. Temporal resolution means that within like 1 second you are able to take so many readings. Okay, high sampling rate, you can also say. High temporal resolution means, yeah, so it can detect changes in brain activity over very short time intervals, typically in the range of milliseconds. So it can capture in 1 millisecond what is happening, other millisecond what is happening, and so on. So it makes EEG particularly useful for rapid dynamics, since the brain activity is very rapid, very dynamic. It's not like the skin response. Skin changes slowly. The brain neurons, they fire very rapidly, and such so that we think so fast and process so fast. That's why we are able to go for this very fast decision making, and hence also we can capture the responses to the stimuli and emotional states, etc. So while yeah, I mean, the temporal resolution is very good. So the answer is true. Now, which frequency band of the EEG signal is associated with the state of relaxation, and often observed when individuals have their eyes closed? Interesting question. Try to answer. Have you ever gone to YouTube like while you're working? What I usually do is to gain more concentration. I put on my headphones and search YouTube for concentration music. Now, this concentration music I found really interesting thing: alpha waves, gamma waves, beta waves. So I was very surprised, like what are these talking about? But then after I read this part, then I got to know what they're talking about. So, anyways, I'll move on to the discussion. There are, okay, delta. Let's see. So, what happens? In our brain, there are so many waves, and there every wave is associated with like different frequency, and they occur typically when they're related to some kind of brain activity. Okay, let's say, let's look into this picture. We have delta waves with the lowest frequency, then theta waves, alpha waves, beta waves, and gamma waves. Now we talk about delta waves. It is very low frequency, means very slowly changing activity. Okay, when do we experience these slow things? When we are like in deep sleep. Okay, and like we don't know what is happening around us. We are in the deep state, deep sleep. We are unaware of our surroundings. Then we are slightly active. Let's say you're dreaming and you're visualizing something, you're imagining something. Okay, then these theta waves occur. Theta waves are slightly higher frequency than delta waves, and trance, you've heard trance or dreaming. So these states are associated with theta waves. Now, alpha waves is usually associated with the state of relaxation. When your eyes are closed, meditation is there. There is some kind of creativity, calmness is associated with alpha waves. Okay, then comes beta waves. So beta waves is for the alertness. See, the more your activity is increasing, the frequency is also increasing. So now the beta waves are more related with alertness or concentration or active thinking. Then gamma waves is when you're like when you're diving deep into the thought process and the synchronization peak experiences. Let's see more examples. So the correct answer for this question particularly is alpha waves, which occur in the this frequency range 8 to 12 hertz, and and they're commonly associated with relaxation. So the meaning is when you're capturing some EEG data, which will give you some electrical signals, and the frequency, if we observe, then if you are relaxed, then you will observe more waves in this frequency range. Okay? Now the brain activity is associated when the individuals are in calm and relaxed state, when their eyes are closed, and this alpha waves are more prominent in the occipital lobe, the back part of the brain, and they are typically reduced when the eyes are open or when an individual is focusing on a task. Um, okay, it has inverse relationship. Let me tell you, it has inverse relationship. So let's say delta waves are associated with deep sleep and unconscious, as I mentioned. Then the theta waves are related to more drowsiness or light sleep, where you are dreaming also or daydreaming also. Then comes the beta waves. Beta waves are associated with the active thinking part, focus and alertness, especially when you're performing some high cognitive load task. So this is alpha. The question was state of relaxation and individuals there having their eyes closed. Okay, there is an inverse relationship between the alpha band power and cortical activity. So the cortical activity means in our brain there is a region called cerebral cortex. So it is responsible for, it has so many components. Different components are responsible for different, uh, let's say, responses of our body. Let's say for this region, I don't remember exactly, but one region is responsible for vision, one is for auditory, and other regions are like for uh, perception, visualization, like that. One is for memory. So alpha waves are often observed in states of relaxation, as we discussed, and these waves are more prominent in the posterior region. That we also discussed, that occipital region. But so the individual is awake but not actively processing sensory information, ठीक है, or engaged in complex cognitive tasks. So the cortical activity refers to brain's electrical activity, because if your eyes are open, you are looking at something. I'm looking at the screen right now. My brain is processing this information. So the cerebral cortex is active right now. The signals will be higher. Okay. Now, but alpha waves are associated with relaxation with my eyes closed. So these are contradictory. They don't occur together. I mean, they have an inverse relationship. So one is increasing, the other activity will decrease. So let's read this out. The alpha wave power increases. It indicates relaxation. However, so again, when I have my eyes closed, the brain isn't processing much visual or sensory information, and the alpha power is higher. So जब मैं अपनी आंखें खोलती हूँ, when I open my eyes and I am engaging in more mental related tasks, so brain becomes more active, and hence in visual and sensory cortices, and then the alpha power decreases. So this is a inverse relationship. Okay, what is a common limitation associated with EEG signals? When we were talking about EEG signal, I skipped some lines because of this question. I wanted you to know. So does it have poor temporal resolution, limited frequency range, poor spatial resolution, or limited signal to noise ratio? Would you like to try? So EEG signals, as I mentioned. Okay, no worries, Krishna. So what happens is, how do we measure the EEG? Like this. So there are so many electrodes placed on the brain region. Okay, and then each electrode reads the brain activity, like this EEG reading. Okay, so like this is like for electrode 1, electrode 2, electrode 3, and there are so many electrodes, and we read the activity. So it is, we have already discussed this, but let's see. It is a non-invasive technique for measuring the electrical activity in the brain by placing electrodes on the scalp. Okay, so it is particularly valuable for studying the brain function real time, because let's say I show you some scary video, the brain should behave a certain way or different than I'm showing you some comedy videos. So you can measure the differences in the parts or which are activated during a certain experiment. So it has several limitations. One limitation is poor spatial resolution. Spatial resolution means if I have a signal, then can I pinpoint like from where this is observed? Although you can say, let's say this electrode is capturing the information from this region, but the signals from other surrounding areas is also being captured somehow. It's not very specific to that region. So there is some kind of noise, I would say. um, yeah, so source, where is the source of this these signals? EEG measures from the surface of the brain. Okay, and this activity is a summation of electrical signals coming from many neurons. This is a broad region that the electrode covers. We cannot like put electrodes in every single point on our brain, so sometimes it is very confusing which region was actually having this specific activity. And in this diagram there are still a number of electrodes, but usually we don't like we cannot have these many electrodes in every setup. So sometimes what happens is, let's say I have 5 electrodes, so each electrode is meant to cover a specific area of interest. So hence, if this is showing some reading, I don't know from where this is being like contributed to the output. Now, if you want a better spatial resolution, then there are other techniques like fMRI, functional magnetic resonance imaging, or MEG, and these provide better spatial resolution. However, one quality of EEG signal was in good temporal resolution. That means within 1 second it can capture a number of times, and it can exactly tell you when did this happen. So they are very good at telling when this happened, but not very good at telling where did this happen in our brain. Okay, so that means the correct answer is poor spatial resolution. Okay, next question. The user's attention is not required for physiological sensing, which aids in emotion evaluation in people with attention deficit disorder. Do you think while you're capturing these physiological signals, you require full attention? So let's think in this context. Okay, true. True. Why? Because other methods of, let's say, in I'm talking in terms of emotion capturing, which we want to capture what a person is experiencing right now, what emotion. Okay. Now there are multiple methods to capture the emotions being felt. First method can be very simple. Just put a camera, record the reaction, use the facial expression analysis to tell what the person is experiencing, right? Very simple, straightforward. But so many factors are involved. Let's say I do not enjoy long videos, or I'm bored very easily. So I won't be able to take interest in your experiment, which is like 20 minutes long. So I might look here and there, and then purpose is defeated. I might not be interested. So let's say I have attention deficit disorder. That means the person cannot pay attention to a single thing more than a few seconds or more than a few minutes. Okay. Although let's say I have put a sensor here on my finger, and then it is reading automatically. Let's say my skin conductance is being checked. The only issue is physical activity. I cannot move here and there if it is more of a restricted, um, the wires are there and everything. So it will restrict my physical movements a bit. However, uh, it can be useful in the case of attention. I don't need to look at it constantly, or I don't need to pay attention. I can just do my work while the sensor is on. Okay. So that is why this physiological sensing is considered better in terms of when we talk about attention deficit disorder, which is ADD. Okay. So yeah, advantages is objective measurement, real time monitoring, sensitivity to subtle changes, and non intrusive. We know. Okay. So yeah, this is true. Okay. Now, arousal and heart rate are tightly related. Whenever you are experiencing some emotion with high arousal state or low arousal state, do you think your heart rate changes accordingly? Are they related? True. Let's take an example of anxiety or fear. So, if you're scared of something, let's say you're walking in a park and then a dog is coming towards you, running, you will experience fear, and then your heart rate will increase. Okay? So, and let's say you are very relaxed after your presentation is done. Now you are chilling with your friends and you're very relaxed, your heart rate will be lower. So yeah, there is a relationship between those. So usually this occurs due to fight or flight response. Whenever there is an emergency situation, it might lead to increased heart rate. And similarly, when arousal level decrease, such as relaxation or sleep, heart rate tends to decrease as well. So true. Then, which of the following statements is true? High HRV is associated with aroused stress from exercise, psychological events or other internal or external stressors. High HRV means you are aroused or stressed from exercise. Low HRV is associated with relaxation. Body has strong ability to tolerate stress or strongly recovering from prior accumulated stress, which are true. Both A and B are true. So high HRV means, read out the statements again. It is saying low HRV is associated with relaxation. Low HRV means low heart rate variability. That means it is very constant. And we mentioned that it is not good that if the interval is constant, 1 second, 1 second, 1 second, it is not a sign of a healthy heart, because your heart is more rigid. It is unable to adapt to the changes or the surroundings. So HRV we've already studied. So the correct answer is neither A nor B, because the first statement tells us high HRV is associated with aroused stress from exercise. We say if like your HRV is low, that means it is constant, like one 1 second, 1 second, and 1 second. That means you are more stressed. You might be experiencing stress or fatigue or health issues, whereas high HRV is associated with good health, ठीक है, and with relaxation. So fourth is correct because it's the quite opposite, ठीक है. Okay, which metric is more appropriate for evaluating heart rate variability data? Is it average interbeat interval or root mean square of successive differences? So I think we should discuss this first. So what is IBI? Okay, Vishwesh is saying B, root mean square of. Let's see, yes. So as I mentioned, if you look at a heartbeat map or a wave, then there are so many peaks and this depression areas, which we label as PQRST. So this wave is usually having these points. Now, when we are talking about the interval in heart rate variability, we discussed about the RR interval, right? So that means the difference between the peaks. This peak is R. Now understand this is why we were saying RRP, because the nomenclature follows this convention. Now what happens is um, interbeat interval. Interbeat interval means again the average time interval between each heartbeat. So RR interval is it also tells us the, let's say after 1 second, 1 second, 1 second. So that means 1 second is the interbeat interval. But if you take average over multiple waves, multiple RR intervals, then it gives you the average. Okay, we will see an example, you will understand. So while it provides some information about HRV that we saw, it doesn't account for the specific changes in beat to beat intervals, which can be important. So next is root mean square of successive differences. So this is a measure of variability in length of consecutive RR intervals. Okay, it specifically quantifies the short-term variations in heart rate, which are influenced by the parasympathetic nervous system, and it is considered as a more sensitive marker. So it is considered slightly better or more sensitive as compared to the IBI. So let's see with an example. So how is this calculated? We have the differences between the distance between this RR interval. So actually distance means time. Sorry for the, I mean, confusion if you are facing, but it means how much time has passed between these two peaks. Okay. Now, so we take the difference between this first, second, third, and then we square them. ठीक है, हमने इसको स्क्वायर किया, and then we add it, then we take the mean, and then we take the square root. So root, mean, squared, successive differences. So let's start with difference. Difference means this. Successive differences means this one, two, three, four, and so on. Successive differences. Then squared. We square this term. ठीक है, then we take the mean of this. We take the mean of this. ठीक है, let's say I have 5 readings, so divide by 5. Then I take the square root. So then we obtain the root mean squared successive differences. Now why is this better than IBI? Let's see. We have two examples here. ठीक है, the difference between these two peaks is, you can see here it has more HRV, right? Higher heart rate variability. This is lower HRV. ठीक है, but if you use this interbeat interval average thing, then you will see the differences here. So ultimately it becomes 650 milliseconds um, by 92 beats per minute. Like this is the same quantity that is observed for both of these graphs. However, if you try to calculate the mean, this RMSSD, then for this we have 313 milliseconds. However, for this is 31. So you can observe that this difference, no difference is observed when compared across beats per minute or RR interval. Okay? Or but then if we take the RMSSD value, it means condition B is more physiological arousing than condition A. Okay? Lower HRV is associated with increased arousal. So that is why this RMSSD is a better metric. Okay? Next question is, which method is less intrusive and cumbersome for measuring heart rate compared to ECG? B. Krishna, would you like to answer? B. Correct. Because we just saw that it is less intrusive and very because in EEG you are surrounded by wires, or ECG, sorry, in ECG you are surrounded by wires. These electrodes are there. Physical movement is very much restricted. However, in PPG you can freely move around. It's a wireless sensor as well. Wearable, exactly. Okay. So yeah, we already discussed this, so I'll just skip this out. However, there's another term called electromyography, and GSR you already know. So electromyography is associated with the muscle activity. So it measures the electrical activity in skeletal muscles. Okay? And these are also measured through some electrodes placed on the body, okay, near the muscles. So yeah, this is PPG. Then emotion is the only factor that affects heart rate and heart rate variability. True or false? False. False. Correct. Because HRV is not just influenced just because of an emotion. My heart rate might increase or decrease also. My HRV might increase or decrease based on other factors. Let's say physical activity is there. Okay? Physical activity, stress, medication. Let's say some medication are also there. बोलते हैं ना कि for heart related diseases some blood thinners or मतलब something is there which can impact your heart activity. Then age, your heart is more like tired, you can say, fatigued. and the activity is of course slowed down as you grow old. Then gender, health conditions can also be there. Let's say somebody has some kind of cardiovascular disease, or environmental factors, temperature and altitude also plays some important role. Okay, so yeah, it is not the only factor which influences the HRV. Okay, GSR are excellent methods to monitor emotional arousal, but they cannot reveal the emotional balance. Interesting question. I hope you answered this one. Okay, Krishna. Okay, Krishna, did you attend the previous lectures or are you starting now? Uh, okay, okay. No worries. So, another thing on a side note, you can go to the previous live sessions because they are recorded and then I upload on a YouTube channel. And also, you can ask the NPTEL team to share the link with you. Most likely, it would have been shared. Also, the slides will also be shared. And I strongly recommend you to go through the lectures and it will help you out. Okay. Um, yeah. So, what emotional, see, let's say I'm experiencing some emotion, okay? So, how will you tell the person is? We usually say happy, sad, tired, like this, okay? We put some labels. This is called the categorical method. Now, second way is more numerical. How can you represent an emotion in the form of numerical data? So, there is something called VA model, which is valence and arousal model. जैसे कि if I tell you to tell me the location of your home, you will tell me some GPS coordinates. ठीक है? So it is a information in the form of numbers which computer can understand. Similarly, if I tell you what emotional state are you currently in, then you can tell me in the form of numbers. How? Let's say valence. So valence is an arousal. So, like x comma y coordinates, we have two coordinates, valence value and arousal value. Now, valence का मतलब ये होता है how happy or sad, how pleasant or unpleasant the feeling is. So, let's say this is the origin, ठीक है? This is the neutral state, we can say. Now, if it is a positive side of valence, then it means happy emotions. And if it is on the negative axis of the valence, then it means some negative kind of emotion. Arousal means you are more activated towards that during that emotion. Um, let's say I would say very happy, ठीक है, or surprised, or you can say very excited. Okay, this is a better example. Excited. So excited, how will you represent? Excited में you are happy, ठीक है? And are you aroused or are you like having more? Are you more attentive? Are you more excited? Are you more active? Yes. So that means positive arousal is there. Positive arousal, yeah, high activity. ठीक है? Positive arousal is there and positive valence is there. So positive valence, positive arousal, that means it lies in this quadrant. So somewhere here you can find excited state. ठीक है? Similarly, if you go for some other state, let's say fear. ठीक है? Fear is, in fear you are more activated, right? So that means positive arousal. And are you happy or are you sad or negative, or it is an unpleasant feeling? So it is an unpleasant feeling, that means on the negative axis of valence axis, so it will lie somewhere here. Exactly. Similarly, for any other emotion, ठीक है. For any other emotion you can um, and this can be represented by a number. Let's say what is valence's value, plus 5 point something, then excitement की value plus 6 point something, ऐसा वाला x comma y. Exactly, now you understood ना. this is the this is called the VA model. ठीक है. So that is how we represent. Now GSR, like skin conductance, it is used to measure the arousal. But can it measure the valence as well? I told you that the skin activity increases. That means the sweat glands are activated. But is it can also tell you that I am happy or not? No. It can only tell about the excited state. Okay? So it cannot provide me the information about whether I'm feeling pleasant or unpleasant. It can only tell me whether my body is in the excited, activated state or not. Okay? So that is why we work on different modalities. Let's say this GSR is not sufficient alone as is to detect what emotion, but when I combine this information with my facial expressions, then I might be better able to understand what exactly I'm feeling. So if I'm kind of smiling, then it might be a positive feeling. However, if my expressions are more on the sad side, you will see that it is more of a negative emotion, like that. Okay. Okay, pick the most appropriate statement. More brain activity means less alpha power and vice versa. More brain activity, less power, but converse is not true. Less brain activity means less alpha power and vice versa. We just discussed that this is a inverse relationship. That means one thing increases, the other decreases. So if less brain activity is there, alpha power will be more. And if there is more brain activity, मतलब कन्वर्स इज ऑल्सो ट्रू ना. दोनों चीजें हो सकती हैं. सो इनवर्स रिलेशनशिप इज देयर. करेक्ट. ठीक है. सो देखो, आप बोल रहे हो कि my brain activity is increased, so alpha power is decreased. Let's say you are in the class, your teacher tells you to solve a difficult maths question. Now your activity is increased, so alpha power will be decreased. But is it also possible to do the reverse, like decrease the alpha power, can we change it? And then our brain activity, you actually do that. uh, the example I took in the concentration music thing. So, and it actually helps some people like me, who cannot focus. So I have some issue, I cannot focus properly. There is so much noise around me. So I need some concentration, some music. And if I play songs, I cannot concentrate. So I play that music. And if that is alpha wave, that means it is inducing some kind of uh, electrical activity in my brain. Okay? It is inducing that calmness or relaxation state, and then it is helping me to focus more. So we can also do the converse. So vice versa is true. Okay? The majority of the times artifacts are present in EEG data. Is it true or false? Easy one. This is true. Okay? EEG, as I already mentioned, we need to place the electrodes on our scalp. Now there can be some noise factors. Let's say even physical movement, you're moving too fast, the electrodes might not stay on your scalp. ठीक है, आप you're constantly moving, it might introduce some kind of noise. Eye blinks is also considered as, like, you have to stay as much stable as you can while uh, you are like being observed for EEG signals. movement can also be there. Some electrical interference can also be there. The sensors are ultimately capturing the electrical activity, and if there is some device which is around those electrodes and somehow it is also emitting the electrical signals, then it is also possible that, let's say you're talking on your mobile phone, so some signals can also be produced which might interfere with the electrodes, so that is a source of noise. Muscle activity, so many artifacts can be there. ठीक है. हाँ. When compared to GSR, the EEG modality better captures the onset of an emotional process. So, as I mentioned, like emotions are more gradual. ऐसा नहीं है, it's not the case that you are experiencing happiness for just a second, like you are neutral, then suddenly you experience some happiness and then you're again neutral. No, it doesn't work like that. We gradually experience. You start feeling that, then it's more like a hill kind of graph, or like this kind of bell-shaped curve, you can say. Okay? So this the time when this you start experiencing the emotion, it is called the onset. This is called the offset, and this is called the apex, like the topmost point, like the highest intensity that you experience. Okay? So these are the cases. Then, true. Okay. So yeah, as we discussed, what is the difference between GSR and EEG? The difference lies in the temporal observations. Okay? So there might be some signals that change very frequently. Let's say, yeah. So the onset of emotion, that means it is progressing slowly. However, if you are talking about the skin activity, it is very slow process. The emotion impact the brain activity much earlier than it shows on your skin or your skin activity. Okay? So if you are comparing EEG with GSR, then of course EEG is faster, like because it is observing the brain activity, and brain is the first thing that is changing. The brain activity is the first thing that is changing. Okay? While you experience an emotion. So EEG provides excellent temporal resolution. We know that, meaning it can detect changes in brain activity with high precision and in real time. And since emotions involve neural processes, in EEG can capture the rapid changes uh, onset more effectively than GSR because it primarily measures the changes in the skin conductance. Okay? Therefore, EEG is preferred. Next, how does the acquisition of emotions through physiological signals differ from facial expressions? It requires mimicking the intended emotion, uh, requires it is less accurate, relies on conscious control, does not require the user to pay significant attention. So, difference between facial expressions and physiological signals. Vishwesh is saying D. Krishna, do you understand the question? D. Correct. Why? Because in the setup where you need to capture the facial expression, let's say I'm capturing sadness. So I tell you to behave in a sad way. Okay? Or you are maybe you want to like pay attention to the video that is being played or the stimulus. However, in physiological signals, you don't have to be conscious about your surroundings. Let's say I tell you ki you have to pose in front of a camera. The camera is capturing your uh, face right now. Okay? So you will be more conscious about it, and maybe you will behave certain in a different way because without any camera or something recording me, I behave in a different way. But when I know that there is some sensor or some camera which is recording my face, I need to behave more properly. I cannot look bad, or I have to behave sad, like that. So it influences us subconsciously. Also, in the case of physiological signals, the electrode is just attached and I'm just watching it. So it is not in my control how my heart is pumping the blood. Okay, it's involuntary and I cannot change it. So I don't require to pay attention like what is happening inside my heart or my brain. It is just happening without my intervention. So yeah, we don't require to pay attention to this setups. Okay, so D is correct. How are ECG signals typically captured? Very simple. Vishwesh, did you read the options correctly? This question is particularly checking about yeah, exactly, because the first glance you will say A is correct, but D is D is the correct one. Okay, so just read the options correctly. Let's skip this. Of course, we know this. Then, which component of emotions does heart rate typically correlate with? Valence, dominance, arousal, effort. Krishna, do you understand this? Sure. हार्ट रेट से हम क्या मॉनिटर कर सकते हैं? वैलेंस, डोमिनेंस, अराउजल और एफर्ट. करेक्ट. अराउजल, because heart rate variability, and we can say in a more excited state our heart rate increases, and in a more relaxed state the heart rate lowers down. ठीक है? So in case of nervousness and anxiety, these are associated with increased physiological arousal in your body and includes a faster heart rate. Okay? And your heart starts to beat faster as your body prepares for the stressful situation. And usually this happens due to the parasympathetic nervous system, which gets activated in situation of danger or more excited states. Okay? So yeah, arousal. Then how does plethysmography PPG measure heart rate? ये भी हम पढ़ चुके हैं. By analyzing electrical changes on the surface of skin, through measurement of pulse signals at various locations of the body, by emitting and collecting light to estimate blood flow, by monitoring changes in blood pressure. Okay, Vishwesh says C. D or C. By emitting. Okay, Krishna, we just discussed that this is, see, this contains photo. Photo means light. ठीक है? As I discussed, that there is a sensor, it emits light, and based on how much is reflected back, let's say your heart is, like whenever your heart is pumping blood, there will be more blood when the pumping is happening. ठीक है? So the nerve will be more, having more expansion or dense, like exactly. So when it will reflect back, how much is absorbed and how much it is able to reflect back, so depending on that, you can estimate that now is the, like, flow is happening, larger flow, and then little less flow is there. So it can help us to measure the pulse basically. Okay. Also the oxygen levels, etc., etc. Why? How can we measure that? Using light. So It emits and collects light. Also, it is a wearable device. Let's see, यहाँ पे picture is there. So when you put your finger in the sensor, or even here in your smartwatch, you can see here, or oximeter like this. So these are the light is emitted, and this is a receptor, or it can also be like this. Okay. So these sensors can capture the amount of light reflected. What is the relationship between heart rate variability and emotional health? Higher heart rate variability, so high HRV is related to poor emotional health or better emotional health, or is it not related? Let's say when you're stressed, or okay, Vishwesh says C. Krishna, what's your take? Okay, cool. Yeah. So HRV, as we have already discussed, that it, yeah, exactly. So it indicates the ability of the body to adapt to stressors, and it's linked with emotional resilience and flexibility. So higher HRV, good emotional health. ठीक है. हाँ, ये भी बहुत easy, very easy question. In context of HRV, what is RMSSD? So this is root mean successive square successive differences. So it is calculated by taking the square root of the mean of the squares of the differences between adjacent RR intervals, the intervals between successive heartbeats over a period of time. So it provides us insights about the parasympathetic nervous system activity, how well it is doing, and is commonly used as an indicator of short-term HRV. Huh. What limitation does heart rate have in determining emotions? It cannot detect changes in arousal levels. It does not provide information about heart rate variability. Um, it cannot differentiate between positive and negative stimuli. It is not reliable in measuring emotional responses. Correct. Heart rate and balance, we've seen that arousal it can tell, but it cannot distinguish whether a state is happy or negative. Okay. What is the typical latency or delay with which the GSR signal responds to a stimulus? 2 to 4 microseconds, 2 to 4 milliseconds, 2 to 4 seconds, or 2 to 4 minutes? Um, 2 to 4 seconds. Okay. Actually, the typical latency is 2 to 4 milliseconds. It means that approximately 2 to 4 milliseconds it takes for the changes in skin conductance to occur whenever you are looking at something, uh, maybe as a stimulus. Then it takes typically 2 to 4 milliseconds for changes in skin conductance to reflect. It starts after the, like, you can say, um, millisecond, like after a delay you will observe some difference in your skin conductance. However, it is a slow process. Don't confuse between the two things. After, let's say, after 4 milliseconds you're observing, and then you keep on, it keeps on the constant value for a few seconds, a few, let's say, some time. Okay, after that, but during that time the EEG signal might change. That means it might give you more correct or precise readings. So these are two different things. Okay, what are the two main components of the GSR signal? Um, Skin conductance response, skin conductance event, skin conductance level, event, response or level, or event or variation. D, event and variation. Let's see. So skin conductance has two main components, which is the response and level. Okay. Um, SCR, that means the response part, it represents the transient changes in skin conductance in response to specific stimuli, while SCL, that means level, refers to the overall tonic level of skin conductance. So let's see what this exactly means. Skin SCR, which is the response part, it refers to the transient changes. These changes are often rapid and short lived, reflecting the immediate physiological response to a stimulus. Okay? Um, Something abruptly changes when you're just looking at, let's say you look at a stimulus and then something abruptly changes. That means it is your body responding to it. Okay? So it can be triggered by various stimuli, emotional experiences, cognitive tasks, or external events. Let's say if somebody suddenly receives a startling or emotionally arousing stimulus, such as a loud noise or frightening image, then their skin conductance may rapidly increase as a part of fight or flight response. Okay? This in the case of sudden, like this is a sudden spontaneous response. This increase in the skin conductance would represent an SCR response. Then it is, then the level is in the picture. It represents the overall tonic level of skin conductance, which reflects the background level of arousal or sympathetic nervous system activity. That means it occurs more slowly, it changes more slowly, and it reflects more generalized changes in arousal rather than specific responses to stimuli. So it can vary based on stress, anxiety, temperature. Or, so it basically, you can say it's more of a overall health or overall measure of that skin conductance. However, response is something that it is observed when there is a sudden thing, sudden stimulus is there. Let's say during periods of heightened stress or anxiety, the SCL may be elevated as the sympathetic nervous system becomes more active, okay? Leading to increased skin conductance even in the absence of specific stimuli. मतलब it stays for a while, okay? So SCL means the level is heightened. So you can see this is some measure. So you can see before the stimulus was there, this dark blue thing, the level was very low. Okay? It is lower level. However, when let's say something happened and then it suddenly jumped to this amplitude, this value. Now you can see for this long duration of time, this is staying constant. Okay? Your overall conductance is, let's say, increased. But you can see here this response is varying. That means this is the more we would say that specific time to sorry, this is the reading that you take, which is more specific, which is more time sensitive, you can say, and it is more precise measure of the skin conductance level. And this happens in response of like something is happening, something constantly. Let's say the dog is running behind you, then you will experience a sudden rise in the conductance. Then you see, look back, there is no dog, you don't see, maybe it drops for a while, but then you spot that again. So this is the constant change. However, this overall, you're already in the heightened arousal state. So overall it is the level, and this is the R response. So EDA means electrodermal activity, which is the GSR. Okay? So there are two components. Okay. Again, what is the purpose of maintaining proper interstimulus interval durations in HCR analysis? To increase the overlap between stimulus responses, to minimize the duration of the GSR response, to ensure a clear separation between stimulus effects, to decrease the amplitude of the SCR. Okay, Krishna. So, why by elimination, Vishwesh? Okay, read the question very carefully. We have already discussed the same question. The words were different. What is the purpose of maintaining proper interstimulus? Interstimulus, what does it mean? Between two stimulus, between two, like video 1, video 2. ठीक है? Why should we maintain proper interstimulus interval durations? This is the sum duration. In SCR analysis, skin conductance response analysis, because it might be possible that you're already in a heightened some state, okay? You're already here, then another stimulus is there, okay? Another stimulus is there, and then again it will peak. But if it is already peaking, then you won't be able to understand, is this peak because of this video 1 or video 2, if you don't maintain the gap. So during this time, the purpose of this time is to bring this to the kind of neutral state. If you look back into this diagram, see, after certain, let's say this is the stimulus, okay? After some time, it is dropping. That means there is some difference. There is some gap between the two intervals. Okay? One peak is observed. Then you see, यहाँ पे it comes down to the base level. Although the base level itself is very high right now, but still it comes to the base level. Then base level, again it jumps back. You can see these drops can be because of the gap that we introduce, and it is very important. So you can see that this reading might be because of video 1, video 2, video 3, like that. So you can judge which video is the most, it in inducing most emotions, most like intensity of the emotions is observed in which video. I hope you understood this. So, maintaining a proper interstimulus durations in skin conductance response, it is to ensure again a clear separation between the effects of different stimuli. By allowing sufficient times, we can accurately assess the response to each individual stimulus without interference from the previous or subsequent stimuli. This helps in analyzing the specific impact, ठीक है, सेम चीज है. Let's say एग्जाम्पल, suppose a participant views on an arousing image that elicits a strong SCR. ठीक है, if the subsequent image is presented too quickly, the participant's physiological arousal from the first image may still be elevated when viewing the second image. The overlapping arousal could obscure the true response to the second image, ठीक है, and lead to inaccurate interpretation of the data. On the other hand, when we maintain a proper interstimulus interval durations, ensuring a sufficient gap is there between each image presentation, then researchers can allow the participants' physical response to return to a baseline before moving on to the next stimulus. Okay? Again, same thing. Okay. Now, what is a common limitation associated with labeling emotions using physiological signals like GSR? Lack of available tools, difficulty in precisely determining the onset and offset, inability to separate SCR and SCL signals, challenge in analyzing the frequency domain of GSR signal. B. Okay. Krishna, do you want to try answering this one? Okay. No issues. Um, okay. We just discussed that the GSR, the skin conductance level, it is it has certain delay as well as it is not that temporally precise. That means if I'm taking a reading, like it's not changing very frequently. Okay? So also it shows up after some delay. Okay? So the levels will start, like it will increase after some delay. So that means the emotional onset and offset that I talked about, the onset and the offset, because the effect will stay for a while. We don't know when exactly the emotion, when I started feeling like that. Okay? So limitation of GSR, let's read this out. It uh, like emotions are complex. ठीक है, emotions are complex and multifaceted phenomena that do not always have clear and distinct boundaries. ठीक है, in terms of onset and offset. मतलब ऐसा नहीं है कि at 1.1 second you will start experiencing happiness and at 2 second you will just stop. It is more like a not a discrete thing but a continuous thing. ठीक है, so physiological signals such as GSR may exhibit changes in response to external stimuli, but accurately identifying the exact moments when the emotions begin and end based solely on these signals can be challenging. Emotions can vary in intensity, duration, and onset latency. Latency means that we just answered the question. After 2 to 4 milliseconds, the GSR shows up. That is the latency, making it difficult to pinpoint when exactly this started happening. Okay? Uh, Using this data alone. So, while physiological signals can offer valuable information, but in these cases what we typically do is that sometimes we take input from the person itself. Let's say that there is a participant in this experiment, so we will ask when, at what point was the turning point where you felt that okay, this is where I'm feeling happy, or maybe some contextual information we can also take. Okay, so yeah, so B is correct. Difficulty in precisely determining the onset and offset of emotions. Now, how fast is the response time of EEG signal typically? More of a factual question. So the resolution or something that you can say that A or D, huh? Okay. No, the response time is 200 milliseconds typically. Okay. It What do we mean by this response time? That means this refers to the time it takes to detect and reflect changes in brain activity in response to an external stimuli. Let's say I'm taking the reading. So again, response time means the latency or something. Okay? 200 milliseconds. I think the previous question, that was GSR wala question, na, it shouldn't be 2 to 4 milliseconds. I also am doubting because it should be more like seconds, 2 to 4 seconds. But I will check that question out, and next session I will tell you the right answer. Okay? Because if EEG is taking 200 milliseconds, how can GSR take 2 to 4 milliseconds? Okay? I think this is correct, but that question is wrong. But let me check first. I don't want to comment. EEG signals have excellent temporal resolution. Of course, we know that it is much better than the GSR in terms of temporal resolution. Okay? So real time, if you want to see that what a person is feeling right now, EEG is a better option than GSR. Okay? Because GSR is more delayed, it has higher latency, higher response time. Okay? So response time is basically how much time it takes to reflect that in in the values. Matlab, let's say initially it was 000 and I start feeling happiness. Now the value should change, but it is still showing 00. And after 200 milliseconds, then it detects that, oh, now it has changed. So that means the latency or the response time is 200 milliseconds. I will check that question out. Okay, what purpose does an amplifier serve in EEG measurement? Converts electrical into chemical, small voltages को amplify करना है, measures the brain's magnetic field, analyzes the neurotransmitter levels in brain. Straightforward question. Hmm. So EEG में क्या होता है कि the electrodes pick up very small electrical signals, minuscule um, electrical signals. This means like very small voltage. So they're very weak signals. क्योंकि our brain is not कुछ ऐसे वो it is not generating some high voltage signals. The neurons are very tiny and the amount of energy it takes to communicate it is also very tiny. ठीक है? So these signals, let's say the values lie in they're very less. So we need to kind of amplify, or you can say magnify the value in order to understand it better. Okay? So we amplify and it can be effectively processed and analyzed. Now the amplifier, it boosts these weak signals to a usable level. Okay? And without distorting or adding noise to the original signal, ensuring accurate measurement of brain activity. Whenever you're working with numbers, na, if the numbers are very small, let's say um, you are using 0.0005, okay, and then you use 0.006, the difference is like 0.0001, okay, but then there is certain difference, okay. बट लेट्स से मैं उनको स्केल कर देती हूँ, 5 बना दिया एंड आई कैन मल्टीप्लाई इट बाय 10,000 ना, तो इट बिकम्स 6 and it becomes 5. Now the difference is much more observable. ठीक है, that is why we use amplifier. वरना why would you need an amplifier? We are just taking out the readings, but the difference is much more magnified and much more identifiable. uh, we might say that okay, between this is just equal to negligible, there is no difference, but when we actually want to discriminate between the two categories, then we might want to rescale or amplify the values. Okay, how are the even numbered electrodes labeled in the 10-20 system typically placed in an EEG? So EEG has a certain, um, you know, like so many electrodes are there. So how will you say कि ये वाली reading belongs to? How can you say this reading belongs to this particular electrode? It will be because of you have some number or some name for the electrode. Okay? So typically it's a numeral system. How is it used? This is called the 10-20 system for EEG electrode placement, and every electrode is associated with a number. And all the even number electrodes typically refer to the electrodes placed on the right side of the head. Okay? All the even number are on the right side, odd number are on the left side. Okay? It is a standardized method because let's say the electrode number one on my scalp is placed here, but on your scalp it is placed here. So it will give you the signal related, but we want a standard location of each electrode very well defined so that we are able to compare the signals. Okay? So let's say such as F2, F6 are positioned on the right side head relative to the midline. So let's see in this diagram, these are some standard ways of putting on the electrodes. So this is the right half. So mostly even numbered. Okay, this is the odd numbered. Okay, this is a standard way. So the question was, how are the even numbered electrodes labeled in the 10-20 system typically placed in EEG? So even numbered are placed on the right side. Okay. Okay. What advantage does increasing the number of electrodes in EEG system offer? Decreased spatial resolution, reduced complexity and intrusiveness, lower cost and simpler data analysis, higher spatial resolution and precision. Correct. Because spatial resolution means how precise you can tell that from where the signal is coming from. Okay? If why do we need more electrodes? It leads to increased complexity and intrusiveness. But it can also enhance spatial resolution and precision. So uh, yeah, it can capture from a larger number of specific locations. And again, let's just see. Say this is the brain region, and I put. Let's say I only use 4 electrodes, so it will give me the whole. It will give me the readings from so 1, 2, 3, 4. So let's say if I observe some kind of signal from 3, so it will tell me that it might have come from whole this region. So now, but I want some specific because within this, so many other uh, regions might be there. Like this might be responsible for vision, or this might be for ears, auditory uh, senses. So different regions might be there. But if I want to pinpoint the location, I might add more electrode for each and every region. So of course, it increases the spatial resolution. Again, in the EEG frequency spectrum, which band represents the electrical activity related to the relaxation and closed eyes? Delta, theta, alpha, or beta? Delta. Relaxation and closed eyes. So the highest frequency was, do you remember I mentioned that highest frequency refers to the high brain activity, है ना? No, the answer is alpha. Why? Delta में what was the case? It is from 1 to 4 hertz, the lowest frequency when you are in deep sleep. It is prominent during deep sleep stages. Slow wave sleep, it signifies brain's reduced activity क्योंकि देखो your brain is idle. When you are in deep sleep, your brain is idle. It's not taking much, cognitive load is not there, no less activity is happening. ठीक है, so frequency becomes more, I mean frequency becomes less. So it would look something like this. This is delta. Theta is slightly higher frequency, let's say this much. This is slightly higher frequency than the delta waves. Theta varies from 4 to 8 hertz. And associated states is like, okay, now you have to move from the deep sleep to more active states. So after deep sleep, what can be observed? It can be early stages of sleep, मतलब जिसको हम बोलते हैं ना कि कच्ची नींद है, मतलब कभी भी खुल जाएगी, ठीक है. So कच्ची नींद और the drowsiness state, मतलब I am very sleepy right now. I'm not sleeping, so I am awake. I mean I am trying to sleep, ठीक है. Drowsiness, relaxation, and the meditative states. But yeah, so theta waves are also linked with creative and intuitive thinking. Then becomes alpha waves. Alpha waves is 8 to 12 hertz and more relaxation. We just discussed that relaxation is linked to the alpha waves. ठीक है, it's commonly observed when the person is awake but not engaged in any mental tasks. Maybe like eyes are closed, daydreaming, meditation, light relaxation. They're associated with calmness and tranquility. Then comes the beta, which are more active. ठीक है, more active when you're actually working on something. So it is associated with heightened mental activity, and it can also indicate states of arousal or stress. Because in arousal, we are more, the brain is functioning more and more, we are more on the higher on the arousal scale, and we are alert, we are focused, performing some kind of cognitive task. Because when you are anxious or you're constantly thinking about something, because your brain is constantly working, problem solving, decision making, or concentrating, ठीक है, तो beta, even while studying, like beta waves. Then gamma is also there, ठीक है. Gamma is the highest frequency when you are very much concentrated, ठीक है, very much concentrated on your work. It requires highest cognitive load is there. Cognitive load, you understand? Let's say I give you um, two tasks. One task is to, let's say, listen to a song of your choice, and second is to solve a maths problem. Now you will find more difficult to solve the maths problem. That means higher load on your mind, है ना? We usually use this term. So higher load means high cognitive load. ठीक है? Cognition is the ability of you to think, related to think, thought process. Um, then the second one will have lower cognitive load क्योंकि आप पे बोझ नहीं पड़ा हुआ दिमाग. So cognitive load can be related to बोझ on your mind. ठीक है. So in case of high cognitive load, this gamma wave is activated. So see, delta is the most relaxed, then comes theta, then comes alpha, फिर beta, फिर gamma. That is how we progress towards the more active states from the less active states. ठीक है. So mostly associated with relaxation and closed eyes, we refer to alpha waves. ठीक है. Okay, what is not a common limitation associated with EEG signals? What is not a common limitation? Poor spatial resolution, expertise, requirements for electrode placement, poor temporal resolution, intrusive nature of the procedure. Okay, Krishna, this one is easy. C, correct. So poor spatial resolution is, of course, there. It is a limitation. Okay, we want to know which is not. So this is poor spatial resolution is there. Of course, when you want to place the electrodes on your scalp, you need to know exactly where it would go. Okay, electrode number will go, one will go here, two will go here, like that. So expert is required. Then temporal resolution, no, it provides a very good, very good temporal resolution. Okay. Then it leads to intrusive nature. Of course, you want to attach the electrodes to your skin, so to your scalp, so it is more intrusive. Pins वगैरह होते हैं electrodes में, like ECG you're going, some pins might be inserted, some, ठीक है, it is very intrusive. So even the need to sit through the session, like EEG, you're not supposed to move. Intrusive is anything that is restricting you from doing your regular activity, ठीक है, or anything that is actually putting on your body and like injecting in your body, let's say needles or electrodes, ठीक है. If there is some skull like cap like structure where the electrodes, you just need to place it, then it is considered less intrusive. But if you need to insert the needles, then of course it is more intrusive. Okay. I think this is the last question, and with this we reach the end of this session. And do you have any doubts, any specific doubts, any specific doubts, any question? Nothing. ठीक है. If you have any questions, you can write in the chat box, even unmute. It's perfectly fine. So next session will be on 18th March, and we will discuss the week 8's content. Same pattern for every session, and these sessions are available on YouTube, as I mentioned. So you can go back. And Krishna, if you want to appear for the exam, I think exam will be in the month of April, so next month. So I strongly suggest you to go through the previous lectures, or even if you also like go through the live sessions, I think that would also be helpful. um, all the sessions are available on YouTube, and these slides will also be shared with you on Google Drive. So there's a shared folder, and if you are not able to access, I think which way the team must have shared with you. Do you have the access to the PPTs? Ha. So NPTEL team has shared with all of you, all the students who are enrolled. So it is easily accessible. And if you still have any doubts, so you're welcome to join the sessions. Like Vishwesh has been joining our live sessions, and so I hope you learned something out of this session. And I try to cover as many topics as possible. Still, if you have any suggestions or anything, so you can please let me know, and we'll work on that. I think we should end the session for today. Thank you so much for joining, and thank you so much for participating. And this session was delayed because of some technical issues, so we it took it very long to complete. But anyways, thank you again. Thank you, Krishna. Thank you, Vishwesh. Okay, I'll see you guys in the next session then. Goodbye. Have a nice day.